audio engineers with the Avid Dolby certified audio application specialist, Sreejesh Nair. Sreejesh Nair owns to his credit a span of 20 years of experience as a sound mixer in the industry. He has worked on more than 200 movies since he started working as an assistant sound re-recording mixer in Rajkamal Studios. He was a part of the first Dolby Atmos Mix Theatre installation in India and the first Dolby Atmos Premier Mix Room in the world. Sreejesh Nair won the 60th National Film Awards for the Best Re-Recordist of the final mixed track for the film Gangs of Wasipur. He is currently working as an audio application specialist at Avid. Let's welcome Mr. Sreejesh Nair on stage with a round of applause. We may now begin the session.
Check. Yes, better. How is everyone? Oh, lovely. Good seeing you all. The best part about these presentations is seeing a lot of familiar faces and friends. And the slightly more challenging part is also realizing that some of these friends are also legendary engineers. So whatever I say on stage has to be taken, I have to understand exactly what I'm saying. My name is Sreejesh, and I'm here to talk about something that's a bit controversial. Don't worry about that. I'm going to talk about artificial intelligence and machine learning for audio engineers. But there's one thing that I won't be talking about because that can spiral off into a completely different direction. We're not going to completely talk about the ethics and things like that because there are so many things that you can take this in different directions. What we are going to do is to just understand what artificial intelligence is, what machine learning is, and if you've seen some of my presentations, I'm not a big fan of maths or technical jargon. So we will be learning this with some pav bhaji and examples like that. Are you okay with that? Lovely. Right. So before I go into what AI and what machine learning is, this is actually what we know it can do, right? Music composition and generation, yes, it can look into things like your score and actually create additional compositions for that. Audio analysis and classification. Now, this is actually a really, really great thing that happened in quite a few years back. I mean, all of us have used isotope RX and plugins like that, right? So one of the first iterations of that whole thing was something that is called source separation, where they could, stem out things. There was quite a few companies that did that. And actually, their technology of the D Russell is slightly based off that. And again, there are things like noise reduction, like de-rustling, which is impossible to perform without machine learning. You can't de-rustle with any of your conventional methods. So there are techniques and things that this offers you, and we'll have a look at how some of these things work. Speech recognition and synthesis. You've all heard about that in the recent times with all of the very controversial songs that were out and the very controversial things that has happened around it. But there is also other things. So there are suggestions that are being put forth where, actors and voice actors can actually lend samples of their voice to be used even for generations later to come as well. So speech synthesis is one thing. Noise reduction and audio restoration, we spoke about that. And source separation and mastering. Now, in the earlier session where you heard two really, really legendary mastering engineers talk about mastering, the one thing they kept telling you was the word magical, the word clarity, the word it breathes. These are things, as of now, you currently cannot explain to an AI system. Like there was a meme that was there some time back. You're safe from an AI because an AI needs to know with total clarity what you want to get from it. So if you work in the film industry, you're completely safe. So I'm just saying, the art of clarity, and which was probably the answer to that question, what was the biggest challenge? The biggest challenge was actually not getting a brief. So imagine working with AI on that, God bless you at that point. So these are the things we know for now it does. Okay? Now it's also interesting to know what is it that it actually does. What is AI? What is machine learning? Because a lot of times these terms are used interchangeably, but they're not. AI is anything that can exceed or match human intelligence. Do you know how far away a throw that is? Exceeding or matching human intelligence. I mean, For human intelligence, the amount of things you can recall in an instant is incredibly high. But more than that, the amount of things you can prioritize and recall is even better. This is why two masters or two mixers will never sound the same. If you use the same plugins, the same EQ, the same rides and everything, two people will always have a different response to these things. So this is why these are certain things that can add a lot of randomness to what is beautiful when it comes to human engineering. Am I still clear? So not a problem, right? Yeah. So what does AI actually have? It has the ability to discover, it has the ability to infer, and it has the ability to reason. But for all of this, it requires data input. It cannot dream these things out of nowhere. It cannot create these things out of thin air. So the ability to discover, and how does it do that? Or the ability to infer. So if you've given it data, how can it actually find patterns in that data and tell you a different perspective of something that you've never thought of before? Or even the other thing of reasoning against you. I mean, we're all mixed engineers and mastering engineers, and if you've mixed, I'm pretty sure that if you've had a creative difference, as long as you can have a beer at the end of the night, it's fine. With the other person, not alone. Okay, that's very important. But you should be able to reason your way around. Why did you move a fader? Why did you have an EQ there? Why did you remove the lows? Why did you add the highs? All I wanted to do was to make sure the voice comes from all around us, drummer is rotating around us. That's what we do in Atmos, right? When you're given 5 speakers, you want to use all the 5 speakers. But there are very specific ways that this can reason with you as well. And the reason I say it is specific is because it does have its parameters under which it works. But there is also an idea, an element of growth in that, which we'll look into right now. So if that is artificial intelligence, then what is machine learning? As with audio, the beautiful thing about all of these terms is it literally means what it's written on that. Okay, that's the fun thing about audio as well. When someone says this is a transform, it is exactly a transform. If you've watched Transformers, you will definitely know Optimus Prime doesn't walk across as Optimus Prime. No? You haven't watched Transformers. Right. So machine learning is actually the capability to make predictions and decisions based on an input data. This is the definition of machine learning. But if you look at this, it does not tell you if your prediction is going to be right, if that is going to be accurate, if that is exactly the same thing, if the person in the toothpaste ad wearing a white coat is a dentist or not. Usually, that is one dentist who's telling you, yes, I recommend this toothpaste, does not mean the entire country's dentists recommend that toothpaste. So you can get skewed away by things. So it does not tell you if the entire set of predictions is right, but it will give you a different perspective to things. And that is where the beauty of this lies as a tool. Remember this. There are things that you can use as a tool. There's a very famous quote that Yuval Noah Harari said, that man has invented a knife, but the knife does not know what to cut with it. But man has also invented artificial intelligence that can think for itself. That's the only invention of mankind that can think for itself, unlike any other ones that we have. So we need to probably adapt and find new ways of using this tool, and also understanding new perspectives of these tools. Right? So this is pretty much as far as I will go into the ethics of this. Right? There are much more than this, and it can actually turn out into a fist fight, which I they're all peaceful people. Right. So then how does this work? How does machine learning work? Now, I'm staying right here at the Courtyard Marriott. Now, what has machine learning got to do with Pav Bhaji? I'll tell you. This is exactly how we learn audio, right? We don't learn about all the technicalities and integration, differentiation, the Fourier transforms and stuff like that. We want to learn in terms of what we can understand. And this is the most simplified version of this. So let's say, I'm staying in Marriott, and let's say I want to have Pav Bhaji. I want to do a room service. I don't want to go out and have food. I'm very lazy. People who know me as a mixed engineer also know that I'm a very, very lazy mixed engineer. That doesn't mean I'll not give your output on time. No, that's a different thing. I'm just lazy. Okay. So now there is this thing of what actually influences your decision on pav bhaji. Say, for example, if I were to ask you, what time did I start this? Roughly what time did I start? 3:10, 3. How many of you actually looked at your watch at this point? Why did you look at your watch at this point? You were trying to estimate a rough amount of time that must have passed from the time I was talking. So you didn't know I started at 3:10. You looked at your watch and said, yeah, it's around 3:20. You must have been talking for around 10 minutes. So we'll estimate it to 3:10. So that's exactly what happened. I don't think you actually looked at the watch when I started this thing. So in the same way, when we're ordering things and when we're doing things, there are actually multiple layers of decisions we go through, right? So if I'm ordering pav bhaji, the first thing that I would want to look at, this is why I want to order, right? Will I save time? Will I want to get up, because in your room, do you want to put on your pants, your shirt, take your keys, go down, wait for the lift, come down, wait outside the restaurant, get inside, take this menu card and order? Or do I want to pick up the phone and say, I want pav bhaji? So the question is, will I save time? So there is a value that, let's call it X1. And to simplify things, 1, if a value of 1, it means yes, 0 means no. Binary, right? Life would have been much easier if everything was binary. It's a yes or no. That maybe that dumb wala plugin and maja nahi hai, maja plugins and things like that would have been much more clearer for us. That is actually where we need artificial intelligence. There is artificial intelligence and there is natural stupidity, but these are two different things, by the way. So will I save time? In my case, let's say, yes, I'm going to save time. Okay. That's a value of 1. So will I lose weight? Am I health conscious and things like that? I'm going to order pav bhaji. I'm not looking at, I'm like a health conscious diet with khaskhas and all of that, and making sure they don't add eggs, and you use only whole wheat grain bread and things like that. No, I want pav bhaji with maska. Okay, so will I lose weight? No, I'm not concerned about. I might not lose weight. Okay, fine. Will I save money? Now, if I'm in the Marriott and if I have Marriott points, I can obviously put it to my Marriott points. So, or if I have a coupon or something, or let's say I called up the reception and said, look, my flush isn't working for the past 2 days, then they'll definitely give you some free food. Although why free food when your flush isn't working is a different thing. That's exactly when you don't want free food, right? But anyways, but that's a beautiful hotel on the side. So will I save money? Yes, let's say I'm going to use my Marriott points. Okay, so 1 is yes, 0 is no. Now, we don't make our decisions just with these 3 things. We assign something that's called a weightage. Correct? So if somebody tells you, look, you have to come to Shree's seminar in hall 2 at 3 p.m. And at the same time, someone's telling you, hey, look, there's free coffee over there. Now you have some decisions to make. Do I go for the seminar? Do I go buy the coffee? Do I go get the coffee? Okay. Now, you would think of this as one or the other. No. You can still get the coffee and come here. So you would think, okay, maybe his seminar might start like 10 minutes late, so I have time to go to the coffee shop and then get that coffee. Oh, but then what if there's a huge queue at the coffee shop? You will assign all of these weightages to your things before you make a decision, right? That's exactly what we do here. There is something that is called a weightage threshold. Let's just put a number of 5 to that. You're going to mark everything out of a value of 5. Okay, we would all have passed our exams if our question papers were marked out of 5. The problem is 100. There are 100 marks. You have to get 35 things correct. If it's 5, it would have been just 3 or 2. Even 2 you will pass. Okay. So let's look at the weightage. Now, will I save time? Absolutely, I'll save time. So I'll assign a weightage of 5 to that. Everybody understands that part? Okay. Will I lose weight? Let's say I am partially health conscious, although I don't look like that. Mujib sir actually told me the most apt description that I've had. I look scattered. I've never heard a more apt description of myself until I look at my Instagram photos. So I don't look at that a lot. Right. So will I lose weight? Nah, I'm not that health conscious, so I'll give it a value of 2. Will I save money? Let's say, no, I give it a value of 3. Will I save money? I'm not really concerned about money at this point. Whether I save, whether I not, it's not going to break my bank, right? Oh, come on, how much will a pav bhaji cost, right? Of course, JW is a different thing. If I go straight to JW and order a pav bhaji, I can get like 20 pav bhajis right from outside, but that's a different thing. Right, so I assign these values to this. Now here is where a very simple calculation happens. Now, we all know we assign a weightage to our decisions, right? But we've also made the decision. I will save time. Will I lose weight? No. Will I save money? Yes. Now, how much of importance do I have to all of this? Will I save time? Absolutely. Will I lose weight? Not that important. Will I save money? Let's say even less important. So, this is the calculation. So, what happens is you multiply each of the value by the weightage you add to it. So, it is 1 into 5, 0 into 3, and 1 into 2. And you subtract that from the threshold. Okay, that is a very simple calculation. Anyone who's done maths in up to 3rd and 4th will understand this. BODMAS, everybody remembers that? Yeah? Right. So when you do this calculation, you arrive at a number. Now, in my case, the answer is 2. And it's a positive value, which means, yes, I should order pav bhaji. This is how machine learning works. Is that simple enough? Now, there are much more complications to this. It's not as simple as thinking this is how it works. But this is the gist of machine learning. Now, if this is machine learning, there is another set of things which is called deep learning. Deep learning is where these algorithms like D. Russell and source separation and even a very, let's say you're building an instrument for a blind person, all of those can also involve machine learning because it can read what you're doing. Let's say if I am a person, if I want to have a piece of music that plays when I'm standing here versus when I'm standing here, I just need to calculate the black and white density of my body. Correct? Yeah, and especially, what better dress to wear than a Batman talking about artificial intelligence, right? You absolutely have to fear the bat at some point. Right. No, it's true, right? And why is Batman so good? He's got money and he's intelligent. Unlike Iron Man, who's got money, intelligent, and a fake heart. That's proof that Tony Stark has a heart, right? Right. So let's look at what is called a neural network. Now, this neural network is actually what differentiates deep learning from machine learning. Actually, deep learning is a part of machine learning, which you will see right now. So this is a neuron. Where else have you heard of a neuron? In our brains, or the neural network that goes to our brains, right? Correct? I also heard it recently only, but there is a department called neuroscience, by the way. It deals with this. So this is a neuron, and it has an input, it has an output. Everybody agrees? That's exactly what you get when you draw a line across a circle. Right? You always have an input and output. I haven't told you which is input, output. Don't worry about that. So if you call the input as Y, and you call the output as U. Why U? Because this is not maths. Maths, if your input is X, your output is always Y. You always have to find your X, like your girlfriend, at some point. But in terms of data science, let's call the input as Y and the output as U. Now, earlier we saw there were two states, like what is yes? 1. What is U? What is no? 0. So if you give it an input, it will either give you a 1 or a 0. Okay, that's a simple form of this. There are things in between. Has anyone of you heard about fuzzy logic? Yeah, that's also how your washing machines work. Sometimes my mom does that as well, fuzzy logic. Do I get the plate? Yeah, get the white one. You go, no, not the white one, the red one. Okay, you go get the red one. No, I asked you for the blue one. That's fuzzy logic. Your decision will be made only at the time of the output. Right. So you have an input, you have an output. Now there are different kinds of diagrams or different kinds of parameters for this. It's pretty much like audio. Like you have an input. If it passes a certain value, it's like a gate. If it crosses a certain value, the gate will open. If it drops below a certain value, the gate will close. And you can have a knee and things like that, right? So there is a sinusoidal. There is something that's called a ReLU or a relative U, where the value of U will gradually rise as the Y goes up. There is another one, the sinusoidal. What will happen is it is either 0, and if it crosses a value, it is 1. There is nothing in between that. No matter how high the Y value goes, it will always be one. So there are these, and there are very much more complex things of this as well. So this one is exactly how a neuron works, and neurons fire. You have neurons firing in your head. Depends if you want it or not also, by the way. You know, when I was talking about loudness, there's a couple of things that affect loudness, and one of the most important thing and most funny thing that impacts loudness is focus. And the reason it is called focus is because I cannot use any other term standing on a stage. When will you lose focus? There are many times when you will lose focus. When you don't sleep, when you had too much fun, when you party, and things like that. So there are many points at which these neurons will fire, and the reason I have not mentioned an input and output is because this can go forwards and backwards. And I'll talk about that. Right. So you place another one. So this goes into one, and that can go into another neuron to make a decision on that. Right. So creating your weightages, and okay, now I've made the decision of, am I going to save time? Yes. Then the next thing is, will I lose weight? Right. So it can go in chains. Now, it can also be in this way. You can have simultaneous ones firing. Now, do you know where we have simultaneous neurons firing? Any other example? When we hear. So if you think about the cochlea in our ear, it is physically capable only of getting audio up to 4 kilohertz. Then how are we hearing all the 5, 6, 10, 12? If you have a manly EQ, the 27K, right? You know, manly EQ has a 27K, right? Of course, it's called the air band. That's the maja part, the one that you cannot understand, but it still works. And the way we hear above 4K is basically what is called a sympathetic neuron firing. So when higher frequencies land on your ear, multiple neurons will start to fire. And then your brain will map those multiple neurons firing. Okay, this is this frequency, this is this frequency, this is this level. Okay? It's like getting beaten up in a riot. You don't know where the hit is coming, but it is coming. Okay, at some point you will understand that. Right, so this is how now this one is only got one layer to this. Now, you can actually extend this to multiple layers, right? Now, if you take the earlier example of me ordering pav bhaji, I could also add the fact that, okay, do I have a meeting now? Is my flush working? Right? If my flush is not working, I'd rather go down and have a pav bhaji. Then do I have to meet someone? Am I acidic? Do I have, let's say, do I have to wake up early in the morning? Do I need only 2 pavs, or do I need to order more pavs? There is a lot of things you can add on to this. When you have more than one layer, so this number, an input, a layer, and an output. When you have more than one layer, it is called a deep learning network. That is when it is deep. Deep comes from more than one layers, and learning comes from machine learning. So that is why it is called deep learning. This is an absolutely beautiful thing, because all of these things in the middle are called hidden layers. And there is a lot of times where we absolutely cannot predict what the outcome is going to be. So the thing with deep layers is, it'll give you an output, but it'll not tell you all the steps to how it got there. It is like us thinking. Like my mom used to ask me, hey, why did you ask me about dosa in the morning? Yesterday when I went out, I saw somebody carrying a sack of rice, and then I thought what would go with it in pulses, and then you have this long chain before you come to the answer. Most of the times we don't understand, right? So it will not tell you how it got to the answer, but it will give you a lot of patterns that as humans we may have not seen, which we can take or which we can disregard. Okay, so these are the different kinds of neural networks which we don't really need to go into. We are not learning data science over here, but one of this is very specific for audio. It's called a recurrent neural network. It's the second one right here in the blue one. You see those orange? What colors are they? I can only see orange and blue. There's one more color. I know it's light. Is it yellow? Yeah. I am blind in all the primary colors, by the way. So I would need all of your help as well. Okay, so it uses a recurrent network for audio. What audio does, the way audio is processed is it sends data forwards and it receives data backwards. It's like filters, right? We have a feed forward filter, which is a high pass filter, and a feedback filter. right? Or a negative filter, which can be a low pass filter. The same thing with this one. So it will send data this way. It can make decisions forwards and backwards. So there is a lot of detailing that happens in these kind of neural networks. So this is where deep learning comes from. Is this part clear? See, AI is not that intimidating to us, right? All we wanted to do was put a reverb to the voice, right? And we'll let AI tell us what to do. Good. So now what is the relationship between all of this? There is AI, there is machine learning, there is deep learning and all of these things, and we are hungry, we want a coffee. We've been sitting on this chair for the past 2 hours, and I'm standing here on a Batman shirt, and I can rant on like this, and where is this going? Now it got a bit random, right? This is exactly what happens sometimes in AI. So what you just heard is probably natural stupidity, but AI is not necessarily like this. Right. We have something that is machine learning. Machine learning can be supervised. Now, how does machine learning work? So in what is called a supervised, it has an ability to create an algorithm of its own. Right? If I'm a programmer, then I have to give every condition possible for it to give an output. Right? If any other condition exists, like if I have a reverb, I only have a pre-delay and a decay. Oh, no, you need to add reflection. I need to program the reflection into the reverb, right? Okay, now you had reflection on this. No, but we need 7.1. Okay, now we do 7.1 and all of that. Oh, no, Atmos is there. We need to have at least 914 or, the client is not going to agree. Okay, now you go and program 914. Hey, by the way, we are also releasing this in NHK, which is 22.2. So you can see how this can scale. So, and you have to program every single thing. Like Batman has no jurisdiction, machine learning has no jurisdiction. Okay, machine learning can actually iterate on these things and create it on its own. So how it does that is, there is something that's called a supervised learning. Now a supervised learning means you will give it a set of inputs, you will label it. You will tell the algorithm, this is what this is. Okay, now all of these tracks are drums, all of these tracks are vocals, all of these tracks are bass. It will listen to it, it will try and create a pattern from that, and then after that, you give it an input without telling it what it is. And then it will try and figure out if that is a bass guitar, if what your output is correct. If it is not, then you go and tweak the algorithm. You give it more data. Now here is the most important thing of all. For this to work, it needs an extensively huge amount of data. For audio especially, it needs an extensively huge amount of data. I was talking to Stefan, and Stefan would ask me, what does your head shake mean? I'm like, Stefan, it depends what part of the country you're from. This can be yes, this can be no. If this is with a smile, that's yes. If this is with a smile, that's also I'm making fun of you. It can go in a varied amount of data. So you need a lot of data to understand what exactly is happening, right? Same thing. Now there is unsupervised learning. Unsupervised learning is where this makes its own decision. This is where deep learning comes into play. Deep learning is mostly unsupervised learning. And that is actually where you will see most of the, sorry, it just went a bit forward. Yeah. So that is where you'll actually see most of the future development going to happen within audio as well. And it's not about taking away jobs. I'll come to that in a bit. But you will see all of the possibilities also that are possible. Then there is reinforcement. Reinforcement is like a reward model. So you give it an input, it gives you an output. Is it right? Then you reward it. If it's not, you punish it. Pretty much like our school. Right? We all have marks. And if you don't have marks, now the punishment is not in the school. We have to get my father to sign the progress report at some point, right? So there is a punishment at that point also. This is also how, it's very amazing how machine learning is very close to us. But they're essentially trying to emulate how we think on this. Right, so you have reinforcements. Now, within machine learning is a sub-path of that is deep learning. It is also a part of machine learning, okay? Now, this whole thing is actually a part of artificial intelligence. Machine learning, deep learning is a part of machine learning, and machine learning is a part of AI. Now, AI has many other subtexts. So NLP stands for Natural Language Processing, which is exactly what GPT is, right? Do you know the idea of GPT when it came by? How long it's been? It was actually a paper that was written in 2017 called Attention is All You Need. There's one single paper from which GPT was created by OpenAI. So there was GPT-1, GPT-2, and GPT-3 was Chat GPT, which is a form of the They have an educational part of this, the Instruct GPT. And then from that, you now have GPT-4. Now, GPT stands, GPT actually stands for Generative Pre-trained Transforms. So it is generating a text, and the model is actually pre-trained on a set of data, and that box is called a transform. Okay. Now, what it means is, so something like Facebook, for example, do you know a rough estimate of how many combinations of words and lines it might have? Like it says, let's say you have a sentence that says John dash reading. It can be likes, it can be love, it can be hate, it can be anything. Now, in general, if you look at the word reading, and if generally all of us hate to read, and if the weightage is assigned to the word reading, then the ML will actually substitute the word with hates. But if it goes and figures out John is the most important thing, and John literally lives in a library, then it will substitute the word loves. And if John is anybody like you or me, he'll probably say likes. If we get, we'll read. If we'll not get, we'll watch. This is exactly how predictive text happens. Now, the way it figures this out is, it figures out, okay, if this word has come, then probably this word or this word is what will come out of that. For that, you look at the context of it. What happened before, what happened after. It's exactly like how we figure out meanings in sentences we don't know, right? Hey, what is the meaning of this, Dad? Probably good. Why? Earlier he says he was a good boy, so I'm assuming this is good, You're too lazy to look into a dictionary, right? All of us. Come on, man. Don't sit there and say, I know all of us are this way. So that is what happens in these kind of machine learning substitution. So there is all of this part where it actually can look at the predictive text. Now, Facebook, for example, has a combination of 170 billion combinations that it has tokenized. You know how big that is, and it is only growing. That is just Facebook. There's a lot of other data also that is out there. So the ads that you see on your phone are probably not a mistake. Like we saw Remover the other day. We were just talking about Remover at the airport, and 2 days later we have Remover on our phone. Right. So this is how it actually works. There's an input, there is a model, there is an output. We all understand this kind of a signal flow, right? Everybody, input, processing, output. The CPU works like that. Input, processing, output. That your DAW works like that. Input, processing, output. What? Your entire audio signal chain is like that. Do you think we are analog beings? Do we listen to things in analog? Yes? You're all nodding because I am nodding as well. Yeah, that's called the mirror effect. No, I mean, think about this. The data hits your ears, goes to your eardrums, it gets converted in. There's a 30 dB boost that happens just because it has to enter the cochlea, and that is called impedance matching, which was exactly the thing that they were trying to figure out earlier by the transformers and all of that. You have an impedance matching that hits into your ear, and at that point, it is actually triggering your neurons, which are transmitting ones and zeros. There is a proper AD conversion happening. And like with every conversion, AD conversion, there will be distortion, there will be coloration, there will be harmonics added to it. You're a living harmonic being. All of that is there. But anyways, we are all listening in digital, so let's not diss digital at that point. Digital is also quite good, although we have our limitations. So there is an input, there is a model, there is an output. Now the question is, how will you create this model? Like if I am a programmer and if I have to give answers to everything, like I'm a programmer who's deciding to use Pav Bhaji, I can't figure out what all combinations of things I'm going to have, right? So that is where we'll have a data and a learning system. The learning system is what actually creates this model. And it'll keep iterating and keep iterating and keep iterating. And the more iterations you have, the better output you will get. How many of you have seen Midjourney or all of those kind of AI drawing tools, right? There was this recent one called Dragon. It was posted as the Facebook, Photoshop killer. All clickbaits we have now, Photoshop killer. Look what happened to this man after he installed this. Then you'll immediately go and click. You'll have to go through 5 minutes of an ad. Anyways, so all of these things actually, the way they work is, they'll create an output, they will match it to see if it is believable enough for a model. If not, it'll go back, reiterate, create. Go back, reiterate, create, reiterate, create, reiterate, until it gets one that is believable enough for the model to match, to say, okay, this looks like the original one that I got. These are matching. That is why when you look at an AI generated, you sometimes see the eyes look dead, like he has got 6 fingers on his hand and things like that, right? Because those are some of the things that are going off. But then when you come to deep fake and deep voice and all of that, that's a completely different topic over there. Anyways, this is how the model is generated. So if I was a company, if I was trying to make a plugin platform that was going to do a de-rustle on my track, I cannot create an algorithm to remove rustle, because the way it works is it has to understand what it is that you're trying to remove first, remove it, and also fill in the blanks. Right? If you remove rustle and you're left with a hole, then you might as well just call a sound editor, right? Now imagine things like all of these things in audio. What exactly happens? Noise reduction, which is the first and most important thing, denoising, equalization, mastering. Now, when I say mastering, of course, you have things like Lander, you have things like e-mastering and things like that. You subscribe for, I don't know, $39, $40 a month, and you can do all of these changes. But you cannot communicate to that particular system like you would to a human being. Like the terms of clarity, the terms of a feel, the terms of openness, the terms that, it needs to breathe. Those are not technical terms you can actually put into a system. That is why you need somebody like us. When the directors or the person says like maja nahi hai, you actually have to go in and figure out if it is more low frequency or if it is just the reverb, or if he wants everything in the surrounds. We don't know. Maja nahi hai is the answer, right? That is why it cannot be fixed by a plugin. That is why you need machine learning. And I'm pretty sure machine learning will go for a very long time on maja nahi hai, because it has to figure out what it is, and by the time it reaches the third iteration, no, the first one was good. Or then you go back to the first, not this one, the second one, third one. Right. Equalization and mastering, yes, there are a lot of things. Now, don't look at this one as the final product. Okay, just because you have an EQ that gives you a preset does not mean that the preset is done and final. Like if you have a preset that says big fat kick, you don't know what the product was before and after. That is probably not meant for your kick to make it fat. It is just called big fat kick because I like to call it a big fat kick. Okay, you don't know what it was. So creating presets for you to start from and things like that, suggesting changes to your tracks. These are things that are very good, because the faster you can get away with the 90% of the work, the more time you have for the last 10% of your work. And the audience will only listen to the last 10% of your work. They don't care about the first 90%. The last 10% is what they're going to listen to. You struggled with the string section and you did all of this. It sounds very good. And then you play it back. Oh, reverb na utna acha nahi hai. How many of us have heard this? Right? So they'll only listen to the last 10%. But getting that first 90% to work correctly, you can save a lot of time in that. Automatic mixing. Now, when I say automatic mixing, does not mean that you take your tracks and you tell the system, okay, I have 3 bass guitars, 4 guitars, 3 keyboards, 1 drum, 2 loops and a voice. Now give me something that sounds like Honey Sing. No, that is not how it works. Okay. There are things that it can analyze, it can position things, it can place things in this, and it can also start off in creating a well-balanced mix that it thinks is a good place to start. It is like if you're a mix engineer, you're getting a well-produced track. Who doesn't like a well-produced start to start and mix, right? And even you don't like, okay, I saw your hand, We have some very few very talented people who are actually extremely good at changing non-well-produced tracks into great hits. Speech to text conversion. Now, this is a huge thing. Speech to text conversion, and the other way also, text to speech conversion. Now, when we look at AI in general, there are some things that we take for granted. For example, the very fact that I'm standing here, walking across, moving my hand, talking to you, creating a filter in my mouth, changing my tongue, moving my lips, looking at each one of you is a coordination of a lot of things. My center of gravity has to be kept stable. The fluid between my ears has to control my balance. It's a very, very, very complex thing. We haven't reached there. Right now, we're still in the primordial soup of AI. So if you think about AI and say, oh, no, if you think about this in terms of Terminator and things like that, no, the robots are coming in, first of all, they need to walk. They need to figure out, this is me and not a dog. That is a wall and you should not crash there. There are things like this that it still needs to figure out. So it can have mistakes. But These kind of things like text to speech, speech to text, especially for blind people, for physically disabled people, for a lot of challenged people, this is a huge thing. Imagine the kind of musical instruments you can create for them to perform. Imagine the kind of a DAW you can create for them to actually work it. The last one, not last one, but this is a great thing. Sound classification. How many of you are sound editors here? Quite a few, right? How many of you have actually used ChatGPT to do sound editing? You should try it out. Explain your scene to ChatGPT and see what comes from it. It'll give you suggestions that you would probably never have thought of. Now imagine having a GPT within your editing section. Right? You want to say, I need a baboon that sounds like a 3-year-old. By the way, this was actually told to me by Bijay Ratnam. I need a baboon that sounds like a 3-year-old child that has morphed into a monster. Fair enough. It'll give you options. Now, if you can search through this, categorizing sounds is a very important thing. Now, this is not just for sound editing. Right? Imagine you're trying to figure out a sound. You want a very emotional, sad blow of wind. The wind has to sound very sad. Now, how do you do that? No, the rain has to feel that agony and pain. Or you put rain over tin sheet. No, that is not, rain over tin sheet is not agony or pain, just noise. So there are these things that you can help classify. Now, it is not just to classify these things, it can also suggest genres of songs for you. Right? You'll end up hearing songs that you've never heard before, or you would probably never have got into and heard. That is an important thing. We want to be able to hear songs and pick on things that we've probably never heard. Why? We are all audio engineers. We want to expand our capabilities. We don't want to EQ looking at the screen. We want to use a... Right? At the end of the day, this is what we want. Adaptive audio systems, and that is also an excellent thing. Which means, like, let's say you have... Now, this is actually a pretty great thing. To be able to take elements in your mix and automatically place them in a space, depending on what it is, doing that automatically or using machine learning to find out the different things or components that make up an instrument and split it. Or even for sound synthesis, you can actually create sounds and instruments that never existed. You can have different layers of different things, one following the other on an envelope, and all of that creating a completely new duduk. Right? Now, if I will call it Sriduk. Right? Why should I change the name? So you can start, and all of these things actually push you in terms of art, in terms of what you're experiencing as a listener and what you're creating as an artist. When the DAW first came, everybody did say that, oh, the tapes would sound better, we would lose all of the analog warmth and things like that. Now we know that is not the case. We still have a lot of fantastic productions that are made in Pro Tools, Logic, Ableton, all of those things, right? It was not the DAW, it was always the artist, right? Plugins, did that bring you back from using hardware? I would say in a form, yes, if you're not an experienced person, because nobody will put 10 LA2As in their track if you could buy one. If you think about the money you spend in buying an LA2A, then you will think about putting more than 2 at some point. Okay, those are very expensive plugins. Very expensive hardwares. Anyways, but these things will always happen. It will actually bring out art in a way that we have never experienced. And as a human culture, as a human race, to experience something we've never done before, it will actually make us adapt to newer things. And newer things will always inspire. So if you look at the possibilities in this, intelligent spatial mixing, absolutely. If it can read and find placements in things like that, it can start off suggesting things that are there. It can actually create a much more immersive mix that is there. New instruments, yes. Help it physically challenged musicians. For example, you can actually have motion-controlled instruments and things like that that are triggering other things. You can have people who are dancers, who are moving across left and right and triggering. You can have adaptive, constantly changing music based on the performance happening on stage. You will never see 2 shows in the same way, just like Ed Sheeran was doing on that loop thing. Have you seen it on Facebook? You've seen that, right? How many of you noticed his shoe change? Right? When, one shot he was wearing red, the other one he was wearing white. But the song was the same, by the way. Ideate and create scratches, that's an excellent thing. If you want to have new ideas, like just asking ChatGPT for suggestions, or just asking if things like that embedded into your software for suggestions, and creating a scratch and then working from somewhere, working from a palette, that's a great thing. New speech synthesis, yes. We never knew how a dinosaur sounded until we saw Jurassic Park. but we were still sold that, this is how the dinosaurs did sound. Why? Because we heard the dinosaur before we saw the dinosaur. Correct? And sentiment analysis is actually a pretty interesting thing. It can actually analyze emotions. Analyzing emotions, so it's a really good tool in, let's say, in social media and things like that. For example, you can actually know if something is going to be pulled out as, let's say there's going to be an inciting speech, or is this a roaring speech, or is this a rewarding speech. It can actually pull these things out, flag them, and track them as well. So there are all of these things that are there, that are possible with machine learning and AI, and I have only told you about the surface of this. And the reason I've only told you about the surface of this is because we need to understand that this is not something we need to be scared of. It is just something that we can use as a tool. That's what I wanted to tell you as well.
Interesting session. I have just a basic doubt. Like when you're speaking about the weightage, can you hear me?
Yeah, I can
We're
hear.
talking about the weightage assigned by the AI.
Yeah.
Like as far as a human is concerned, the weightage could be a factor of your experience.
Correct.
How does an AI get a weight assigned to it? Does it come under supervised?
That's a very good question. So when you assign, it starts off with a set of weightages, it gets the output. Is that the desired output? Like I was talking about supervised learning, unsupervised learning and all that. Is that the desired output? No, go back. So there is a reiteration that happens. It's called back propagation. It'll go back, it'll change these values until it finds the right thing. Like even when we have weightages for us, if you're doing all of this, we ordered all of this, like I ordered pav bhaji and everything, and suddenly I have a meeting downstairs, I will have to go downstairs. There are things that can change at last minute as well. It is exactly like how we function. This doesn't work? No. Then rechange this. This doesn't work? No. Rechange until it comes to the right answer. This is why I was saying there are a lot of times when these answers may seem right. Like the person in the white coat telling you this is the toothpaste I recommend. It is not necessarily right. It can give you a prediction. It does not have to be right. That is the human part of us to choose whether that is actually what you want or no.
Hi.
Yeah, hi.
Actually, I wanted to ask that deep learning and CNN is much involved in other sectors like automobiles and computer vision, machine vision, industrial automation, but it is not that much involved, and there is means उतना involved नहीं है और उतना industry में adapt नहीं हुआ है AI for music. उसका क्या reason रह सकता है?
It is, first of all, it is a starting off thing. AI has a lot of prominence when it comes to visual data, when it comes to motion things, when it comes to things you can see and compare. The thing with audio is it needs just an incredibly huge amount of data. See, for example, if you talk about a CNN network, let's say a convolution neural network. Now, if you have an image, the way it does is it looks at every sections of blocks of this and it tries to figure out, right? If I do this, what number is this? What number do you think is this? Why? Did you see 4 anywhere? No. And you're also looking at from the opposite side. But you still figured out it is 4. This is the same thing that the CNN will do. Now, this thing for audio is very different because emotionally and in terms of the complexity, audio is very deep. It is not like a visual data that you have. So breaking it into layers, finding the intricacies and all of that actually requires a lot of data before it can reach at some point. So a lot of those additional neural networks that I spoke about are now being experimented in audio as well. So this is why CNN is not that much of a thing, but recursive neural networks are being used a lot.
So good afternoon.
Good afternoon.
Sir, I have this a personal opinion of mine that rather than just being users of these tools, we should also have a stake in creating them. So I would like to know your opinions if audio engineers should actually focus on coding as such.
Not
as skills
necessarily. No, coding per se is something that will die out soon. We don't need to write code to understand a lot of things, but we need to send feedback. Is this exactly what you intended? Like if you're doing ChatGPT, for example, you can create different regressions of that, different versions of that. You need to send feedback. Like let's take this thing. If we have an issue with our software and we ask, okay, can you write to the manufacturer? How many of us have done that? You don't even do that, right? And they will actually help you. I can tell you. So rather than coding, it is always good to have an understanding of what this technology is capable of and how you can actually utilize it. And a lot of machine learning and artificial intelligence depends on backpropagation or how much data you feed back to it. And remember, there is a very important thing which I haven't mentioned, which is called biasing. Now, biasing is one of the points where ethics of AI actually comes into play. If you keep feeding it a certain biased condition of something of data, it will always stick to that data. It will not give you the right answer. This is why sometimes you have a lot of these issues on AI-generated tweets and images and things like that. So you have to make sure you're very diplomatic, politically correct. Yes, that is the word. Democratic in your responses.
So, one more question. So, yes.
Yeah.
So, how AI or ChatGPT has influenced your working pattern? Right
My
now?
working pattern.
Yeah.
So for me, ChatGPT has given me ideas. It has given me newer points to think about. It has given me different points of explanations, and it has also given me the strength to look if what it is actually telling me is true or not. So I'm also being able to update myself and also being able to learn things that I never thought of. That's it. And thank you all so much for coming. Such a pleasure to see all of you. And thank you, Palm, as well, for this opportunity to talk.
Well, it looks like our audio engineers in the audience were quite thrilled with the session, right? Nice. It's good to have you, sir.
Thank you.
I would now like to call upon Mr. Anil Chopra to present a small token of appreciation to Mr. Sreejesh Nair.
Thank you.
It's always an honor to have Sreejesh here. And I think after this lovely session, we have some big sound engineers also over here. I would like, with the permission of Sreejesh, to have a photo op before we hand over the certificate. And I will hand over the certificate in a little while. So I would like to invite Donald Whelan on the stage. He is from London, and he is known for mastering a lot of Bollywood tracks. And please welcome Donald Whelan. We especially invited him from London to join because a lot of big Bollywood tracks are mastered by him. I would like to invite Tom from Hive, the owners of Palm. And he's come from London to see the show for the first time. And I would like to invite Shantanu Hudlikar on stage, and Aditya Modi and Vijay Benegal, if they can also join us on stage. And of course, and KJ Singh, please. Yes, KJ Singh, can you join us on stage? Yes, and Mujib Dadarkar, please, also. So we'll have a good photo op, and then like to give the certificate for speaker to Sreejesh Nair, and a big round of applause. Director Smita Rai. Thank you, everybody.